This Calc 1 video is for initial value problems. Now that you know how to find an antiderivative, and let's review that really quickly. If you're taking the integral of 2x dx, you would add 1 to the exponent of x to the first. So 1 plus 1 is 2. And you would divide by that new exponent, giving you, when you divide out your 2's, x squared plus c. Remember, c is some constant because we are finding a family of antiderivatives. When we solve an initial value problem, what we're doing is we are actually finding this c. We're finding that constant. We now know one particular solution that satisfies some initial information that I'm given. Thus, the name of these problems called initial value problems. So let's look at an example together. Your directions ask you to solve the initial value problem. Here is my derivative that I am given, and this is my initial info that I am given. Y of 0 equals -1 means this. When x is equal to 0, then y is equal to -1. So let's start. The very first thing you're going to do is you are going to multiply both sides of this equation by dx. So these dx's divide out, and on the right hand side you now have a dx. So you are looking right here. I often will skip this entire step and go from here to here. Your next step is to integrate both sides of your equation. I'm integrating both sides of this equation. So on the left, I am integrating dy, and on the right, I'm integrating 10 minus x dx. This is one that's understood to be in front of my dy. So when I integrate 1 with respect to y, that's like having a 1y to the 0 dy. When I integrate that, I will get y to the first over 1, or just y. On the right, when you integrate 10, and I'm just going to do this term by term, that's the same thing as having 10 dx. And when I integrate that, I will get 10 y to, 10 x to the first over 1. When I integrate x, that's x to the first. So I will get x squared over 2. So again, when I integrated 1 dy, I got a y. When I integrate with respect to y, when I integrated 10 with respect to x, when I integrated x with respect to x. So this line simplifies to y equals 10x minus x squared over 2 plus c. So now I am ready to use this initial information that I was given. Please remember that we said that this information means when x is 0, then y is -1. So I literally am going to plug in 0 for every x, -1 for y, and solve for c. So when I do that, here's my -1, here's my 0 for x's. So this will be 0, this will be 0 plus c, so I have c is equal to -1. So my initial function was 10x minus x squared over 2 minus 1. Because when I take the derivative of this, I will get that thing right there. So this is your answer for what c is. This is my initial equation. The second and last problem in this section is to solve the initial value problem you're given on page 2 of your notes, but you need to notice that you are given a second derivative. I'm given this information about my first derivative and this information about my original equation. So since I am given the second derivative here, I'm still going to multiply both sides by dx. And on the right, I'll get 2 minus 6x dx. But on the left, this divides out with the 2, leaving me the antiderivative of this expression right here. So I am now going to, just like last time, take the integral of both sides of this. So here's the integral of the right, here's the integral of the left. Okay, listen carefully. When you take the antiderivative of a second derivative with respect to x, you get the first derivative with respect to x. On the right, the antiderivative of a 2 is a 2x to the first over 1. The antiderivative of 6x is 6x squared over 2 plus c. 2 goes into 6 3 times. So I'm looking at dy dx is equal to 2x minus 3x squared plus c. Here's the initial value information that goes into this equation right here. When x is 0, y is 4. But it's the first derivative. So when x is 0, the first derivative for y will equal 4. These are 0, so I just get c equals 4. Now let me say right here, no. You will not always just get out this number for c. You have to plug in what you are given. So I am now looking at this equation. I am looking at dy dx is equal to, I'm going right here, 2x minus 3x squared plus c. So now I'm going to start my process all over again. I'm going to multiply both sides by, whoops, c was 4. Let me back up here. Okay, c was 4. So now I'm going to multiply both sides by dx. So I get dy is equal to 2x minus 3x squared plus 4 dx. I am going to take the antiderivative of both sides. The antiderivative of 1 with respect to y is y. The antiderivative of 2x with respect to x is 2x squared over 2. The antiderivative of 3x squared with respect to x is 3x cubed over 3. The antiderivative of 4 with respect to x is 4x plus c. The information that I'm plugging in this time is right here. So y is 1 when x is 0. So c is equal to 1. So my equation, and again I'm going right here, is y equals x squared minus x cubed plus 4x plus c was 1. You can put this in order if you want to, it doesn't matter, but here is your answer. And yay, finally, a short video. So you are finished with initial value problems.